Hi 8th grade, this is Miss B here with lesson 7.01, and today we are learning how to solve linear inequalities and represent their solution on the number line. Let's begin by going over our do now. So for problem number 1, it says circle possible values for x that would make the inequality true. So we have the inequality 4 plus x is less than 17. So we're thinking about numbers that we would add to 4 that would be less than 17. There are two ways that we can approach this problem. We can either take values, so for example 0, and substitute them for x and determine if they're true. So we get 4 is less than 17, which is true, therefore 0 is part of the solution. It would take quite a while for us to substitute all these values. So what we can do is treat this inequality as an equation and simply solve for x. So since x is on the left-hand side, we're going to subtract the constant of 4 on both sides, and we get that x has to be less than, x has to be less than 17 minus 4, which is 13. So all the values on our list that are less than 13 would make this inequality true. So all the values that are less than 13, x, right on the side, x must be less than 13. So now we can go on ahead and look at all the ones that are less than 13. So everything up until 13, because what happens when we do substitute 13 into this inequality, we get 4 plus 13 is less than 17. So we're checking to see if this is true. 4 plus 13 is 17. 17 is not less than 17, so this value is not part of the solution set. So 13 and 20 in this case are the only two values on our list that wouldn't work. Let's take a look at number 2. Circle the possible values of x that would make this inequality, 20 divided by x less than or equal to 5. Right, so again, we can substitute these values, or we can go on ahead and solve for x. Right, so we can create a proportion here. So 20 over x is less than or equal to 5 over 1, and we can cross multiply. So the result will be 20 times 1, which is 20, is less than or equal to 5x. And to get x by itself, we would divide by 5 on both sides. And now, one thing to be very careful with is we have x on the right-hand side of the inequality symbol. So let's make sure that we keep it on the right-hand side when we simplify. So x is greater than or equal to, depending on which position you read it, there goes the bell, 4. All right. If you wanted the variable to be on the left-hand side, then just make sure that your inequality symbol, think of it as a Pac-Man mouth. The Pac-Man mouth has to be eating the same value. So we can say that 4 is less than or equal to x, which is the same as x would have to be greater than or equal to 4. So let's look at all the values on our list in which x is greater than or equal to 4. So 0 is not greater than 4, half is not greater than 4, right? 4 is less than or equal to, right? It has the second part, 10, 20, 30, and 40. So all of these values would make our inequality true. So I'll just show you by substituting. So let's take 10, right? Let's say we substitute 10. 20 divided by 10, we're checking if this is actually less than or equal to 5. 20 divided by 10 simplifies to 2, and 2 is less than 5, so it works for this inequality. The examples that we have for our classwork today are very similar to what we just did for the do now, and we're going to also represent a solution on the number line. So again, we're going to treat this inequality as we would an equation and solve for the variable. So since I have my variable on the left-hand side and I don't have any variables on the right, I'm going to leave negative 3x where it is right now. I'm going to start by adding 4 on both sides, so I can combine my constants, and we have negative 3x is less than or equal to 18. So to get x by itself, we have to divide by negative 3 on both sides. And now here's the very important part with inequalities. Anytime you divide by a negative coefficient, anytime you divide by negative, the rule is that you must change the direction of the inequality. So instead of less than or equal to, x must now be greater than or equal to the value on the right. So 18 divided by negative 3 is negative 6. So to represent this on our number line, we're going to find negative 6. And there it is. And to show that negative 6 is part of the solution set, we are going to put a closed circle. Let me shift that over a little bit. We're going to put a closed circle right above 6 on the number line. So all the values that are greater, that's the second bell, that are greater than negative 6, oh, what am I doing? I'm on positive 6. Sorry, guys. So all the values that are greater than negative 6 are to the right. So you're just going to draw an arrow above your number line. So negative 5 is greater than negative 6, 0 is greater than or equal to negative 6, 6 is greater than or equal to negative 6, anything going in this direction. Anything to the left, right, if we substitute it into our inequality, is going to give us a false statement. Let's take a look at the next example. Okay, so now we're on example 2, and it's the same idea. Your goal is to get the variable by itself. So let's draw the line going down our inequality symbol to make sure we keep our work organized. And this time we have our variable on the right-hand side. Nothing on the left, so we're going to start by combining our constants. So I'm going to go on ahead and leave my variable on the right, and I'm going to start by adding 22 to both sides. Negative 7 plus 22 is positive 15. Keep our inequality going in the same direction. Is less than negative 5n. And again, to get the variable by itself, we're going to divide by that coefficient. And notice that we are dividing, last spell, that we are dividing by a negative coefficient, which means we're going to have to change the direction of the inequality symbol. So we'll have that n is less than negative 3, right? So if you want this if you want the variable to be on the right, we can say that n is less than negative 3. So these two inequalities, even though they're written differently, are the same exact thing. Okay, so let's represent this on our number line. Find negative 3 on the number line. And this time, since negative 3 is not part of the solution set, we don't have that or equal to, we're going to leave an open circle to say negative 3 doesn't work here. Negative 3 is not less than negative 3, so we don't want to include that in our solution. And all the values that are less than negative 3 would work. So everything that's less than negative 3 is to the left of negative 3. So that's how we would represent this one. And finally, let's take a look at one more, example number 3. Okay, it's the same idea. We just have a few steps over here, a few extra steps. Draw your line down the inequality, keep your work organized. Now we have a set of parentheses that we need to eliminate. And the way that we get rid of parentheses are by applying the distributive property, multiplying each term on the inside. So we have 4p outside of our parentheses. We can't combine that with anything just yet. 2 times p is 2p. 2 times 7 is positive 14. And all that is less than 8. So now let's go on ahead and combine our like terms. Since it's on the same side of the inequality, we can combine 4p and 2p to 6p plus 14 is less than 8. We're going to subtract the constant on both sides. 14. So 6p is less than 8 minus 14 is negative 6. So now finally, to get p by itself, I'm going to extend this down a little. We're going to divide by 6 on both sides. But now this time, since we're dividing by a positive coefficient, we're dividing by positive 6 on both sides, we don't change the direction of the inequality. So p is less than negative 1. So it's not changing the direction even if you're dividing a negative and a positive number. You're only changing the direction of the inequality symbol if your coefficient that you're dividing by is negative. So we're going to represent p is less than negative 1 on our number line. Let me clear some space here. So we're going to find -1. We're going to put an open circle because -1 is not less than -1. And all the values that are less than -1 are on the left-hand side. So we'll draw an arrow representing all these different possibilities for the inequality.